Welcome back to this channel. In this video, we want to look at how to convert BCD, into binary system. We want to look at how to convert BCD to binary system or binary number. First, you know that binary is the same thing with 2 or to base 2. How to convert BCD to base 2? You know that BCD simply means binary coded decimal. And what it means is that BCD is also a type of number system or a type of decimal numbers that represent digits ranging from 0 to 9. But they have 4-bit code. They have 4-bit binary code. 4-bit So BCD is a type of number system that represents the decimal numbers with 4-bit binary code. So now how to convert from BCD to base 2 or to binary is, assuming we have something like, we have 1, 2, 3, 4. Assuming we have 1, 2, 3, 4, BCD, and we want to convert it to base 2. To base 2, we have it that the first approach is to separate each of the number, and then find the binary equivalence of each of the number. And how do you do it? First, here we have 1, we have 2, 3, and we have 4. What is the binary equivalence of 1? The binary equivalence of 1 is 1. And because BCD is a number system that has 4-bit binary code, it will have it as, we have to write 1. The remaining figures, you complete it with 0. So we have here 0, 0, 0. So now it is now having 4 binary bit code. So for 2 now, we also have to find the binary equivalence of 2. And the binary equivalence of 2 is something like this. If we say 2 divided by 2, we have it that 2 divided by 2 is 1, remainder 0. And 2 divided by 1 will give us 0, remainder 1. So the binary equivalence of 2 is 10. So we write 10, and then the remaining bit we complete it with 0. So we have here 0 and 0. We look at 3. What is the binary equivalence of 3? The binary equivalence of 3, we have here, let's say 3, 2 divided by 3. We have here 2 divided by 3 will give you 1, remainder 1. 2 divided by 1 give you 0, remainder 2 divided will give you 0, remainder 1. So it means we have here 1, 1. And so when we come over to this place, we have it as 1, 1, which is 11. And then we complete the rest with also 0. We have here 0, 0. And for 4, what is the binary equivalence of 4? The binary equivalence of 4 using the same approach, we have here, let's say 4 divided by 2. 2 divided by 4 will give us 2, remainder 0. 2 divided by 2 will give us 1, remainder 0. And 2 divided by 1 give us 0, remainder 1, equals to 1, 0, 0. So when we come over to this place, we have it as 1, 0, 0. And then the remaining 0, to make it 4 binary bit code, we add 0 at the back. So it means converting 1, 2, 3, 4 to BCD what we will now have will be equals to 0, 0, 1, 0, 0, 1, 0, and 0, 0, 1, 1, and 0, 1, 0, 0. So this is to base 2 now. So this is how we can convert from BCD to binary. Assuming, but if we want, assuming we have, but if we have a number like, assuming we want to convert 0, 0, 1, 0, 1, and something like 0, 0, 1. If we want to convert this number, which are in BCD, to base 2 or binary, first of all, remember that BCD is a number-based system that contains 4-bit binary code. Therefore, what it implies is that we have to divide this number into 4. Then we have it as, from here to here is 4 bit digits. So we have 1001, 1001, and from here to here is also 4 bits. So we have here as 0010. So now, having grouped it into 4-bit code, as you see now on the screen, the next step is to convert it to base 10. If we convert it to base 10, we have it as, remember that this is in base 2, so when you are converting it to base 10 now, we are using 2. From here now, this is 0, this is 1, this is 2, and this is 3. If I say 0 times 2 raised to power 4 is something as 0, and 0 times 2 raised to power 3 will still give you 0. But 1 times 2 raised to power 1 will give us 2. So we have here as 2. Come over to this place. If we say 1, here is supposed to be 0, then here 1, 2, and here 3. So 1 times 2 raised to power 3 will give us 8. Give us 8. Give us 8. Because 2 raised to power 3 is 8. 0 times 2 raised to power 2 is 0. 0 times 2 raised to power 1 is also 0. And 1 times 2 raised to power 0 will give us 1. So plus 1. Meaning we have 9 here. So equals to, altogether we are going to have 29. We are going to have, this equals to 29, 10. So the next approach now is to convert this 2910 to binary, which is base 2, which we have it as 29 2 divided 29 will give us 14 remainder 1, and 2 divided 14 will give us 7 remainder 0. 2 divided by 7 will give us 3 remainder 1. 2 divided by 3 will give us 1 remainder 1. And finally 2 divided by 1 will give us 0 remainder 1. And this will be equal to, you will count from here to here. This is called most significant bit. And this place is called the least significant bit. So we'll count from the most significant bit to the least significant bit. So we have here as 1, 1, 0, 1, 2. And this is going to be the final answer. So if you are converting these figures to base 2 or to binary, you are going to arrive at 1101 as the answer.